Okay, so we're going to continue on with what we're doing last time, which is called completing the square. And we just sort of started getting into how we do these problems. So again, the idea is we put all the variables on one side and we put the numbers on the other side. Then we look for a number that we would add to each side that would make one side like x plus some number squared. And then we add that number to the other side, and we take the square root of both sides. And that's how we kind of do this stuff. But let's go ahead and take a look at a problem here. I think we only did one of the two here, so let's go. We'll start with this one. Okay. First things first, we need some of their rights. There we go. All right. Just those little space here. Okay. So as we said, we need the variables on one side, we need a number on the other side. So this guy has got to come over here. And all we have to do that is move him to the other side and switch the sign. So we start off, we're going to have x squared minus 2x, give us some space, equals positive 35. Okay? So then the moral of the story is we take the number that is in front of the x term, in this case, -2. And just standard practice is we always take that number and divide it by 2. Okay? So we go ahead and -2 divided by 2 equals -1. Then we take the -1 and we square it, which just gives us +1. So that means we're going to add 1 here and add 1 here. Okay. So again, the reason we do this is then that turns this into some version of a perfect square. And in this case, it's going to be x. And then it's the number right after we divide it by 2. So x minus 1 squared. So if you FOIL x minus 1 times x minus 1, you will get this guy back. So these two are the same. Then on the other side, we have 35 plus 1 is 36. Okay, so now once we do that, then we take the square roots of both sides. And we notice in this one, notice before we were getting some kind of ugly answers, but that's not going to happen this time. So what's going to happen this time is we take the square root here and the square root here. This gives us just x minus 1 equals square root of 36 is 6. But now remember, there's a plus version and a minus version. Okay, so it's plus or minus 6. So what this really tells us, since we're getting nice numbers, is this guy would actually have factored. So you could have factored this guy too. But the point of the story is that completing the square works for any square root function or quadratic function. Okay, and then sometimes you will get nice numbers, which means, well, I could have factored that if I'd have noticed. All right, so then the last thing we need to do is we just need to add 1 to both sides. So again, there's two answers here. So one answer is x equals 1 plus 6, which is 7. And the other one is x equals 1 minus 6, which is 5, negative. Okay, so there's our answers. So 7 and -5. So if you look at this guy, we had x squared minus 2x minus 35. We could have done our little x thing. I don't have any room for it, but could have done something like, hang on, see if I can find a little space for it someplace. So like up here, we could have said, okay, I've got minus 35 on the top, and I've got minus 2 down here. So since it's negative 35, we know one of them has to be minus. So if we make this minus 5 and 7, no, it's plus 5 and minus 7. There we go. then that would give us, adding them together to -2 and multiply together to give us -35. So that'd be x plus 5 times x minus 7, and then of course you switch the signs when you solve it, so you get the 7 and the -5. So that one would have factored. Okay, but that's a good example to show you that even ones that factor, you can use this completing the square thing and still come up with the right answer. Any questions? Okay, let's go ahead and try a few more. Okay, so same deal here. We need to move this guy to the other side. Okay, so we do that, then we have 5n squared minus 3n equals, let me leave a little space here, equals 15. Actually, we'll leave space on the next one. All right, so there's something a little different going on here. Notice we have a 5 in front of the n squared. Now, in previous problems, notice it was just m squared, x squared, x squared, x squared. You get the idea. There was no number in front. So that presents a new challenge, of course. For this completing the square thing to work, you need just an n squared. So what does that mean? That means we have to divide everybody by 5. So let's do that. And we're going to get some ugly fractions, unfortunately. Okay, so then we're going to have n squared, because the 5's will cancel, right? Minus 3/5 n equals 3. Move that equals sign over a little bit. Nope, didn't take. Hang on. All right, so let's move him over. Like that. Okay. So now, unfortunately, we have to take this number and divide it by 2. Now remember, dividing by 2 is the same as multiplying by 1/2. Okay, so let's go ahead and do that up here if we got a little space. So if we do minus 3/5, and we take that times 1/2, I know I'm writing over top of this stuff, that would give me -3/10. Okay? And then to figure out the number we're adding on, we have to square this guy. So -3 and -3 is 9, and 10 times 10 is 100. So this is the number we're adding to each side. So 9 over 100. And over here we've got 9 over 100. Okay? So yeah, this one gets ugly. I agree. All right, so then what we do here is, remember, the number before we squared it, or the number after we multiplied it by 1/2, is the number that goes here. So this is going to be n minus 3/10 squared equals, now here's what we're going to do. We're going to do a little hack here. So 3 is 3 over 1. So if we want to turn 3 into something over 100, it would be 300 over 100. So the reason I do that, then this is 9 over 100, and voila, we have a common denominator, right? And I'm obviously going to have to copy the slide over for the next one. We'll do that now. So we'll come back to him here in a little bit, but yeah, we're definitely running out of space. Okay, so let's come up here. So then we're going to have n minus 3/10 squared equals 309 over 100. Okay, so then we square root both sides. Color change, I think. So we take the square root here, we take the square root here. So this is just going to give us n minus 3/10 equals, I'm going to leave this as the square root of 309 on top. And that's going to be plus or minus. And then the square root of 100 is just 10. So that works out because now they both have 10 for the bottom. So then I move the minus 3/10 to the other side, he becomes plus 3/10. So this one is definitely an ugly answer. So we get n equals 3 over 10 plus or minus the square root of 309 over 10. Now the lazy math guys might put both those numbers over 10. It could be written that way. You don't have to write it that way. I'm okay with this. But I'm just saying, like, if this was a multiple choice answer, the answer might actually be n equals 3 plus or minus the square root of 309 over 10. They might write it that way. Chances are, if we did this problem using the quadratic formula, it would end up looking like this. But like I say, for what we did here, I'm perfectly fine with that. They're the same thing either way. One of them is just they're being lazy. They don't want to write the 10 twice. So they put it underneath the whole thing. Whew, that was ugly. Fortunately, they're not all that bad. That's about as ugly as these things get. Yeah, exactly. Okay, good. So, yeah, that one was kind of a rare event. I don't think the next one's going to be quite so bad. Let's take a look at it. So let me pop it up here, get rid of all this stuff in case we need the space. Give me a second here. Yes. All right, so for this one, standard procedure says we've got to move the 44 to the other side, right? Let's do that. So he's going to come over here. He'll become plus 44. So now I have 4w squared plus 12w equals positive 44, right? Okay, so this one, same deal. We've got a number out front, but when we divide, we're not going to get ugly numbers like we did on the last one. So we just do this. We go divide by 4, divide by 4, and divide by 4. So this one we end up getting w squared, and then 12 divided by 4 is 3, plus 3w, plus some space. And over here we've got 44 divided by 4 is 11. And we don't need a plus sign there, we need an equal sign there. Please. All right, so that doesn't look nearly as bad. So we still have to deal with fractions a little bit, but not nearly as bad. Let's just talk about that one. So we don't like when we get odd numbers in front of the w, because then when you divide it by 2, you get 3, and you divide it by 2, you get 3 halves. Okay? And then we square that. 3 times 3 is 9, and 2 times 2 is 4, so you get 9 fourths. So plus 9 fourths and plus 9 fourths. Okay. So again, what we can do is this guy here is going to be W plus 3/2 squared, right? And that equals, all right, so what we'll do here is 11 is 11 over 1. So if we put it over 4, we have to multiply the top by 4. So we're going to have 44 over 4 and then plus 9 over 4. Okay. So then that'll give us 44 and 9, that's 53. So let's move up here. All right, so we got W plus 3 over 2 squared equals, so 44 and 9, that's 53, and then over 4, like that. All right, so time to square root it. Let's go ahead and do that. So we square root this side, square root this side. So we're going to get W plus 3/2 equals plus or minus square root of 53. I think it's just the square root of 53. I don't think we can do anything with that guy. And then over the square root of 4 is just 2. So you can do these individually. Square root of 53 is the square root of 53, but the square root of 4 turns out to be 2. So that works out good. Then the last thing we need to do is we need to move this guy to the other side and make him negative. So we have W equals minus 3 over 2 plus or minus the square root of 53 over 2. And again, they could write it with just the 2's underneath the whole thing. So that would be the same as saying minus 3 plus or minus the square root of 53. Looks like 33 up here, doesn't it? That's a little better. And then all over 2. So either answer is fine. I know it's a terrible looking 3 as well. So again, these are about as ugly as these get. But the point of the story is that these things for completing the square, this is done when we can't factor. You can still use it if you can factor, as you saw, but typically if we realize we could factor, we're probably going to factor it rather than do this. Still okay? Okay. All right, the fun continues. You know what, I'm just going to go ahead and copy this one now, in case we need the space. There we go. Okay, so this one's already set up. Now we've got the 3 out front, right? So let's divide everybody by 3. But this one I think is going to work out pretty nice. So divide by 3, divide by 3, and divide by 3. So then I'm going to get R squared plus 6R. So we got an even number there. That's nice. So we're not going to get fractions. Equals 7. Sweet. Okay, so this one's not so bad. We're going to do 6 over 2. Always divide by 2. It gives me 3. And then take the 3 and square it. Not quite sure why I put a plus sign there. Forget that. So we do that, and that's going to give us 9. So we're going to add a 9 here and add a 9 here. Okay? So remember, this guy here is going to be something squared, x and a number squared, right? The number is this guy. Right after you divide by 2, that's the number that's going to go here. That's a useful little hack rather than sitting here and trying to factor this guy again. You just know that's what it's going to turn out to be. Okay? And over here, we've got 7 plus 9 is 16. All right, square root time. So we square root this guy, square root this guy. So you get x plus 3. And that's going to equal plus or minus, and the square root of 16 is just 4. So we got some nice numbers here. All right? Okay. So then all we have to do is move this 3 to the other side. I'm going to have x equals negative 3 plus or minus 4. Okay? So that means this guy is going to be x equals minus 3 plus 4, which is just 1, right? Or it's going to be x equals minus 3 and minus 4, which is negative 7. So that's our two answers. So the moral of the story here is this guy could have been factored. And the first thing we would have done here was we would have factored out a 3, right? And then we would have got r squared plus 6r equals negative 7. Or no, just r squared plus 6r minus 7 equals 0. And then you could have factored it. But it still worked out. All right, let's go ahead and check out the next one. All right, so this guy. So again, we've got a number over here already, but we still need to bring this guy to the other side by making him positive. Let me just get out of highlighter mode. That would probably be a good idea. So we'll move him over here. He'll be positive 20, right? So plus 20 in here. So then we're going to have 2v squared minus 10v equals 8 plus 20 is 28. Okay. So again, we could divide everybody by 2. Because this only works if the front guy out front is just a 1. Like 1v squared. So these will cancel out. We'll have v squared. Then minus 5v. So we're going to get the fraction thing going on again, unfortunately. Equals 14. Okay. So again, what we do is we take the 5, divide by 2, and then we square it. So 5 times 5 is 25 on top, and 2 times 2 is 4 on the bottom. Okay, so then this will be v. Well, actually, we're going to add these here, and then we'll get to that. So 25 over 4 plus 25 over 4. Okay. So then this guy here again is going to be just v, and then I forgot the minus sign up here. It's going to be v minus 5 halves squared. Okay, so this guy over here, let's do a little side calculation. We got 14 over 1. You want to make that over 4. So multiply top and bottom by 4. 14 times 4, I think, is 56, but let's make sure. 14 times 4. Okay, 56, cool. All right. So then this would be 56 over 4. And then we're going to add the 25 to it. So we get the 25 over 4. That just makes it easier to add these guys together, right? So 54 and 25. That's 56, my bad. I don't know why I wrote 54. Let's try it again. So 56 plus 25. So it's 81. Oh, okay, so that works out nice. So this is going to be 81 over 4. I don't know what that is. It's like some kind of weird Greek letter or something. Let's fix that up. All right, take 2 over 4. All right, so now we're going to square root. All right, so we're going to move up here. So we're going to have v minus 5 over 2 equals plus or minus, remember when you take the square root, plus or minus square root of 81 is 9, and the square root of 4 is 2. So we got fractions, but they're not too bad, are they? Okay, so then the final step is to move this guy over here, make him positive. So we got v equals 5 halves plus or minus 9 halves. Okay, so the first one, we add them together. 5 plus 9 is 14, so that's 14 over 2. So that means your first answer is 7. And the other one, we do 5 minus 9. So 5 minus 9 is negative 4 over 2, and that's minus 2. So the moral of the story is this one would also factor. And again, what we'd have done when we started this problem, if we were using factoring, we'd have factored out a 2 from everybody. Okay? So again, when you're completing the square and you get nice answers, that means it probably would have factored. But sometimes it'll factor, but it'll factor when like one of them's a regular number and one of them's a fraction, which is a little more of a pain if you're trying to do factoring. So sometimes it's better off to do this version. Still good? All right, let's maybe do a couple more and we'll call it. Maybe just one more. We'll see how it goes. All right, so it says find the area of the triangle. It says if necessary, round to the nearest hundredth. So the first one says the area of the triangle is 8. So I'm going to go ahead and copy this one too, because with all this stuff, we probably need the space. All right. So area of a triangle is, get out of highlighter mode. All right. So area of a triangle is 1/2 the base times the height. So this thing is going to be 1/2 the base, which is x plus 4, times the height, which is x. And that is going to equal, in this case, they're saying 8. So it wants to figure out what x is. Okay, so first things first, we don't like fractions, right? So let's just go ahead and multiply everybody here by 2. All right, so that cancels out the fraction. So on this side, we just have x plus 4 times x equals 16. Because we multiplied everybody by 2. So we multiplied the 2 by 8, we get 16. Okay? So then if we multiply these two guys together, just destroy that 4 over there, we're going to get x squared plus 4x equals 16. Okay? All right, so standard procedure says we take the 4, the number in front of the x, divide him by 2, we get 2, and then square that guy, and we get 4. So we're going to add 4 here and 4 here. Cool. Okay. So we know this first guy here is going to be just x plus 2. Remember, it's this number here. So x plus 2 squared. And then over here, we've got 16 plus 4. That's going to be 20. Cool. All right, square root time. Do that. So we square root this guy, square root this guy. So we're going to have x plus 2 equals plus or minus the square root of 20. All right, little side calculation in this one. Square root of 20. Remember we were doing this bit where we reduce the square roots? Well, we can do this one. So the first perfect square is 2 times 2. That's 4. And we know from our times tables that 4 times 5 equals 20. And the square root of 4 is just 2. So this turns into 2 square root of 5. Okay? All right. So then our other maneuver that we had to do is we have to move this guy over here and make him negative. All right. So I'm going to write this in the box because we need the room. Let's get something we can see in the box. This guy. All right. So then this is going to be x equals, move the 2 over, he becomes minus 2, plus or minus the square root, well actually it's 2, hang on, let me fix that. So plus or minus 2 times the square root of 5. Let's fix that up. So 2 times the square root of 5. That's our answer. Okay. So honestly, there's nothing wrong with the answer 2 plus or minus the square root of 20. I'm just telling you that if it's on like some sort of standardized test, they're going to write it as 2 square root of 5. Okay. That kind of stuff that would not be an issue if you buy yourself a TI-30XS for about 15 bucks. Because in that calculator, you go ahead and type in the square root of 20, you hit your equals button that says, oh yeah, 2 square root of 5. It just does it for you. It's a good calculator. All right. Well, that seems like a pretty good stopping point for today. We can wrap this up next time. So I want to thank you two for showing up. Appreciate it. Got attendance already, so we're good to go. And so we'll wrap this up again tomorrow.